Installing an above-ground swimming pool near buried electrical cables and water lines presents safety concerns. It's important to understand the potential risks and the requirements of the National Electrical Code, or NEC, to ensure a safe installation. One major safety concern is the risk of electrical shock. A 240-volt underground cable poses a potential electrical shock hazard if it comes into contact with the pool water or any metal components of the pool. Secondly, there is the risk of pipe damage. Excavating for the pool installation could accidentally damage the well water line, leading to leaks or contamination of the water supply. Now, let's discuss the NEC requirements that are relevant to this situation. NEC Article 680.4 states that electrical wiring for swimming pools must be installed at least 6 feet away from the inside wall of the pool. NEC Article 300.5 specifies the minimum burial depth for underground electrical cables. NEC Article 406.9 addresses the requirements for metal conduit or raceways used to protect electrical cables near swimming pools. According to the information provided, the 240-volt cable is buried at the minimum required depth of 24 inches. However, the outer wall of the pool will be 5 feet away from the buried cable, which is less than the 6-foot clearance requirement specified in NEC Article 680.4. Because of the potential dangers involved, it is highly recommended to consult with a licensed electrician for the following reasons. 1. Inspecting the 240-volt cable location and depth. 2. Installing additional conduit or raceways to extend the cable protection above the pool water level. And 3. Grounding the pool properly to prevent electrical shock. Confirm the exact location of the well water line by contacting the well installer or a plumbing professional, and ensure that the pool installation will not affect the well line. When excavating near the buried cable and well line, use hand-digging tools to avoid accidental damage. Based on the information provided, it appears that the installation of an above-ground swimming pool near the buried electrical cable and well line may be feasible, provided that the recommended safety measures and NEC requirements are followed. However, it is essential to have these factors professionally assessed before proceeding with the installation. A licensed electrician can conduct a thorough inspection of the electrical system and ensure that it meets all applicable codes and standards. The electrician can also provide recommendations for additional safety measures, such as installing a ground fault circuit interrupter, or GFCI, to protect against electrical shock. Additionally, a plumbing professional can assess the location of the well water line and ensure that it will not be affected by the pool installation. The professional can also provide recommendations for protecting the well line during excavation. Keep in mind that electrical codes and regulations can vary depending on the location, so it is important to consult with local authorities to ensure compliance with all applicable requirements. It is also important to follow the manufacturer's instructions for installing the swimming pool and any related equipment. Failure to do so could void the warranty and create a safety hazard. In addition to the NEC requirements, there may be other safety considerations to take into account. For example, it is important to ensure that the area around the pool is properly fenced to prevent unauthorized access. It is also important to have a safety plan in place in case of an emergency. The plan should include instructions on how to shut off power to the pool and how to contact emergency services. Swimming pools can be a great source of enjoyment, but it is important to remember that they can also be dangerous. By taking the necessary safety precautions, you can help to ensure that your pool is a safe and fun place for everyone to enjoy. Let's dive deeper into the relevant NEC articles to provide a more comprehensive understanding of the code requirement. NEC Article 680 covers the installation and wiring of swimming pools, spas, hot tubs, and other similar installations. This article addresses a wide range of safety concerns, including the prevention of electrical shock, the proper grounding of electrical equipment, and the protection of electrical wiring from physical damage. As mentioned earlier, NEC Article 680.4 requires that electrical wiring for swimming pools be installed at least 6 feet away from the inside wall of the pool. This requirement is intended to prevent people from coming into contact with electrical wiring while they are in or near the pool. The 6-foot distance is measured horizontally from the inside wall of the pool. In addition to the horizontal distance requirement, NEC Article 680.4 B also specifies vertical clearance requirements for electrical wiring above swimming pools. The vertical clearance requirements vary depending on the voltage of the wiring and the type of pool. For example, for a residential swimming pool, electrical wiring that is insulated for 150 volts or less must be installed at least 10 feet above the water level. Electrical wiring that is insulated for more than 150 volts must be installed at least 14 feet above the water level. NEC Article 300 covers the general requirements for wiring methods and materials. This article addresses a wide range of topics, including the types of wiring methods that are permitted, the installation of underground wiring, and the protection of wiring from physical damage. As mentioned earlier, NEC Article 300.5 specifies the minimum burial depth for underground electrical cables. The minimum burial depth varies depending on the voltage of the cable and the type of location. For example, for a 240-volt cable in a residential area, the minimum burial depth is 24 inches. However, the minimum burial depth may be greater in certain locations, such as under roadways or in areas subject to heavy traffic. In addition to the minimum burial depth requirement, NEC Article 300.5 also specifies requirements for the protection of underground cables. The cables must be protected from physical damage by being installed in conduit or by being directly buried in the earth. If the cables are directly buried, they must be installed with a warning ribbon placed above the cable to alert excavators to the presence of the cable. NEC Article 406 covers the requirements for receptacles, cord connectors, and attachment plugs, or commonly known as outlets and plugs. This article addresses a variety of safety concerns, including the prevention of electrical shock, the proper grounding of electrical equipment, and the protection of receptacles from moisture. NEC Article 406.9 covers the requirements for receptacles located near swimming pools. This section requires that all receptacles located within 20 feet of the inside wall of a swimming pool be GFCI protected. A GFCI is a device that is designed to protect people from electrical shock. If a GFCI detects a ground fault, it will quickly interrupt the flow of electricity, preventing a potentially fatal shock. In addition to the GFCI protection requirement, NEC Article 406.9 also specifies requirements for the location and type of receptacles that are permitted near swimming pools. For example, receptacles that are located within 10 feet of the inside wall of a swimming pool must be weather resistant and must be installed in a weatherproof enclosure. Let's consider some additional safety measures that can be taken to further reduce the risk of electrical shock around swimming pools. One important safety measure is to install a bonding grid around the pool. A bonding grid is a network of conductive wires that are connected to all of the metal components of the pool, such as the pool walls, the pool ladder, and the pool pump. The purpose of the bonding grid is to equalize the electrical potential of all of the metal components, reducing the risk of electrical shock. Another important safety measure is to ensure that all electrical equipment used near the pool is properly grounded. Grounding is the process of connecting electrical equipment to the earth, providing a path for electricity to flow in the event of a ground fault. Proper grounding can help to prevent electrical shock and can also help to protect electrical equipment from damage. In addition to the safety measures discussed above, it is also important to educate people about the dangers of electricity and the importance of following safety precautions around swimming pools. People should be warned not to use electrical appliances near the pool and not to enter the pool during a thunderstorm. They should also be instructed on how to shut off the power to the pool in the event of an emergency. Now let's consider the potential consequences of not following the NEC requirements and safety recommendations for swimming pool installations. One potential consequence is electrical shock. Electrical shock can cause serious injury or even death. Even a non-fatal electrical shock can cause burns, muscle spasms, and other health problems. Another potential consequence of not following the NEC requirements is fire. Electrical fires can be caused by faulty wiring, overloaded circuits, or damaged electrical equipment. Fires can cause extensive property damage and can also put people's lives at risk. In addition to the safety risks, there are also legal consequences of not following the NEC requirements. Building codes and regulations are designed to protect public safety, and violations can result in fines, lawsuits, and other legal penalties. Therefore, it is essential to follow all applicable codes and regulations when installing a swimming pool. In conclusion, installing an above-ground swimming pool near buried electrical cables and water lines presents potential safety concerns. By understanding the NEC requirements, following safety recommendations, and consulting with qualified professionals, it is possible to minimize the risks and ensure a safe and enjoyable swimming pool experience. Always remember that safety should be the top priority when installing and operating a swimming pool. Let's continue to explore the nuances of ensuring electrical safety around above-ground pools, specifically addressing how to mitigate risks when dealing with buried cables and proximity to other utilities. The National Electrical Code provides a framework, but practical application and understanding of these guidelines are crucial for safety. When assessing the installation site, consider the soil composition. Different soil types have varying levels of conductivity, which can affect the spread of electrical current in the event of a fault. Drier, sandy soils are less conductive than moist, clay-rich soils. This doesn't negate the need for adherence to NEC guidelines, but adds another layer of understanding to the potential risks. When the buried cable is within close proximity, consider using ground-penetrating radar, or GPR, to precisely map its location. While utility companies typically provide records, GPR can offer a more accurate, real-time view, particularly useful for older installations where records may be imprecise. It is also important to consider the type of cable installation. Older cables may have insulation that is more susceptible to degradation over time, increasing the risk of faults. If there is any doubt about the condition of the cable, consulting an electrician to perform an insulation resistance test, also known as a mega test, can provide valuable information. This test applies a high voltage DC current to the cable and measures the leakage current, indicating the quality of the insulation. If the insulation is compromised, consider options such as rerouting the cable or encasing it in a protective conduit. When installing conduit, ensure it is rated for direct burial and is resistant to corrosion. PVC conduit is a common choice, but for added protection, consider using rigid metal conduit, or RMC, especially in areas where the cable may be subjected to physical stress. Regardless of the conduit type, ensure it is properly sealed to prevent water ingress, which can compromise the insulation and increase the risk of faults. Grounding and bonding are critical for electrical safety around pools. The NEC mandates specific requirements for grounding and bonding to minimize the risk of electric shock. The goal is to create an equipotential plane, ensuring that all metallic parts in and around the pool are at the same electrical potential. This minimizes the voltage difference that could cause a shock. The bonding grid typically consists of a solid copper conductor, usually number 8 American wire gauge, or OG, that is connected to all metallic parts of the pool structure, including the pool walls, ladder, handrails, and any metallic equipment associated with the pool, such as pumps and filters. The bonding grid is then connected to the grounding system of the electrical service. In addition to the bonding grid, it is also important to ensure that all electrical equipment is properly grounded. This means connecting the equipment to the grounding electrode system, which typically consists of a ground rod or ground plate buried in the earth. The grounding electrode system provides a path for fault current to flow back to the source, tripping the circuit breaker and de-energizing the circuit. Ground fault circuit interrupters, or GFCIs, are essential for protecting against electrical shock. GFCIs are designed to detect even small imbalances in current, which can indicate a ground fault. When a ground fault is detected, the GFCI quickly interrupts the flow of electricity, typically within a fraction of a second, preventing a potentially fatal shock. The NEC requires GFCI protection for all receptacles located within a certain distance of a pool, typically 20 feet. It is also recommended to use GFCI protection for all electrical equipment associated with the pool, such as pumps and filters. Furthermore, consider installing an equipotential bonding conductor or EC to connect the pool's bonding grid to the grounding system of the house. This ensures that the pool and the house share the same electrical potential, reducing the risk of voltage differences. When excavating for the pool, it is crucial to exercise extreme caution near buried utilities. Before digging, always call 811 to request a utility locate. This service will mark the location of underground utilities, helping to prevent accidental damage. Even with utility markings, proceed with caution, especially when working near marked lines. Use hand tools to carefully expose the utilities before using any power equipment. If a utility is damaged, immediately contact the utility company and do not attempt to repair it yourself. It is also important to consider the placement of pool equipment. Locate pumps, filters, and other electrical equipment as far away from the pool as possible. This reduces the risk of water splashing on the equipment and creating a shock hazard. Ensure that all electrical equipment is properly enclosed in weatherproof enclosures to protect it from the elements. Regular inspections are essential for maintaining electrical safety around the pool. Inspect all electrical equipment, wiring, and connections regularly for signs of damage or corrosion. Replace any damaged components immediately. Test GFCIs monthly to ensure they are functioning properly. Simply press the test button on the GFCI and verify that it trips. If the GFCI does not trip, it should be replaced immediately. Consider hiring a qualified electrician to perform a comprehensive inspection of the pool's electrical system at least once a year. This inspection can identify potential problems before they become serious hazards. When choosing an electrician, ensure they are licensed and experienced in pool electrical systems. Ask for references and check their credentials to ensure they are qualified to perform the work. Remember, electrical safety is not a one-time task but an ongoing process. By following these guidelines and taking the necessary precautions, you can help to ensure a safe and enjoyable swimming pool experience.